All right, this is lesson 3.7 involving absolute value equations and inequalities. So, to solve equations and inequalities involving absolute value, that's our objective for this lesson. So we're going to see a lot of equations with the absolute value sign in them and inequalities, and I'm going to show you guys how to solve those. Okay, so let's review what is absolute value. So let's take the absolute value of any number, right? So let's take the absolute value of 4. The absolute value is 4. The definition of absolute value is its distance from 0. So let's find 4. Let's put a little dot on it. And its distance from 0 is 1, 2, 3, 4 spaces. So we went 4 spaces to get to 0, so the absolute value of 4 is 4. Let's try the absolute value of -4. So the absolute value of -4, we're going to find -4, put a little dot on it, and we're going to track 1, 2, 3, 4 spaces to get back to 0, so the absolute value of -4 is also 4. So absolute value, again, is a distance, so it's always going to be positive. So regardless of whether you're taking the absolute value of a positive number or a negative number, you will always get a positive result. It's the distance from 0, okay? All right, so solving an absolute value equation. What are the solutions of the absolute value of x equal +2 equals 9? Graph and check the solutions. Okay, so what we do when we have the absolute value in an equation, okay? Step number 1 is to isolate the absolute value. Oops. Okay, so do you remember in the past when we used to isolate our variable x, right? Now in this case, we're going to treat this whole thing, the absolute value of x, as our variable, and we're going to isolate the whole thing. So in order to isolate this, we have to subtract 2 first. So this is the absolute value of x plus 2 equals 9. We have to subtract 2. The reason we're subtracting 2 is because we want to get everything that's on the same side of the absolute value, which is our +2. We want to move that over to the other side. So we're going to subtract 2. These will cancel on this side, and we're going to be left with the absolute value of x only on the left equals 9 minus 2 is just 7. Okay? So step number 1, isolate absolute value. We have our absolute value is by itself on that left side. Okay? So we're golden so far. And our last step, okay, so step number 2 is to have a positive and a negative solution. Okay, so if I told you that the absolute value of x equals 7, what could x be? Well, x could obviously be 7, okay, but x could also be -7, okay? So you're going to write 2 solutions for that scenario, okay? A positive one and a negative solution. And on our number line, we're just going to put -7. Let's make 0 here, and let's put +7 over here. You are just going to put dots on +7 and -7. Okay? Because our solution can only be those 2 values. All right? Now, the reason we're not shading anything is because it's x equal to 7 and x equal to -7. Not greater than, not less than. Okay? So we're just going to put dots on those values. Okay, next. We're going to do the same thing, okay? So we're going to follow our same 2 steps. So step number 1, let's isolate our absolute value. So we've got absolute value of n minus 5 equals -2. Step number 1 tells us that we need to get the absolute value by itself. So let's add 5 to both sides. When we do that, these 5s are going to cancel. We're going to be left with absolute value of n equals 5 or -2 plus 5 is the same as 5 minus 2, which is going to be 3. And then our second step, so step number 1 is done. Step number 2, we're going to write a positive and a negative solution. So let's write a positive solution, n equals +3, and then our negative solution, n equals -3. When we graph it, here's -3, here's +3, here's 0. Nice dots on both of them because our answers can be positive and -3. All right, solving an absolute value equation. So we are going to be given some scenarios where there's more than just a variable inside the absolute value. Notice here how we have 2x minus 5. Now, we're going to follow the same steps. These steps will work regardless of what we're dealing with. So number one, we're going to isolate absolute value. Now, our absolute value is already isolated, okay? Why? Because there's nothing on that left side that's outside of the absolute values, okay? So if we had absolute value of 2x minus 5 and then a plus 3 equals 13, we would have to get rid of this plus 3, right? Because it's outside of the absolute value. Now in our case, there is nothing outside the absolute value, right? So we are good to go ahead and get started. So we've already done this. It's just 2x minus 5 inside the absolute value equals 13. So what we're doing for step number 2 is we're writing a positive solution and a negative solution. So 2x minus 5, we get rid of our absolute value, equals positive 13. And then we have 2x minus 5. This is going to be our negative solution, equals negative 13. Okay, so you're making the right side of the equation or the opposite side of the equation positive for one solution and negative for the other solution. And then we go ahead and solve. So we're going to add 5 to both sides. 2x equals 18, divide by 2, and we get x equals 9. So that's one of our solutions. That was with 2x minus 5 equals positive 13. And then we're going to find our second solution by doing 2x minus 5 equals negative 13. So we're going to add 5 to both sides. We get 2x equals negative 8. Divide by 2. X is going to be equal to negative 4. So we have x equals 9, x equals negative 4. In this case, we have two solutions now. Okay? Solving an absolute value equation with no solution, okay? So, same thing here. Our absolute value is this portion right here. So what we want to do is we want to isolate this. So we're not going to deal with the 2z plus 9 yet. We're just going to keep that as kind of like our variable, okay? So let's rewrite it. So step number 1, we're going to isolate. So 3 times the absolute value of 2z plus 9, oops, not a parentheses, absolute value, plus 12 equals 10. First step, remember, we don't want to divide by 3, not yet at least. We want to get rid of this 12. The reason we want to get rid of the 12 is because it doesn't have any absolute value next to it. So we're going to subtract 12, okay? So it's 3 times the absolute value of 2z plus 9 equals, these canceled, and now we've got 10 minus 12, which is just negative 2. Now we want to divide by 3. So the absolute value of 2z plus 9 equals negative 2 over 3. Okay, we've isolated our absolute value, so we're done with our first step, okay? Now our second step, remember, is to write a positive and a negative solution. So second step, we've got we're going to take away the absolute value, so we're just going to write 2z plus 9 equals positive solution, 2 over 3, and then we're also going to write our negative solution. So 2z plus 9 equals negative 2 over 3. Minus 9 from both sides. This becomes 2z equals, these canceled. Remember, 2 over 3 minus 9, we can't do that. We have to find a common denominator. So what we're going to do is change that 9 into something with a 3 in the bottom. And 9 times 3 is 27. Okay, so now it's going to look like that. So now we've got 2z equals 2 over 3 minus 27 over 3 gives us negative 25 over 3. Divide by 2 to both sides. z equals, this is going to be negative 25 over 6. Remember, we're just going to change flip. So this becomes negative 25 over 3 times 1 over 2, which will then just give us 6. Oops. Where's my eraser? Okay, next one. 2z plus 9 equals negative 2 over 3. Same thing here, guys. We're going to subtract 9 from both sides. We're going to get 2z equals negative 2 over 3 minus 9 is negative 2 over 3 minus 27 over 3. 2z equals negative 29 over 3. Divide by 2, divide by 2. Z equals negative 29 over 6. And those are our two answers. So yes, this one was a little bit more complicated because there were large fractions, but guys, we cannot be intimidated by these large fractions, okay? You got to remember how to simplify these, okay? Yeah, here. This slide was solving an absolute value equation with no solution. Remember how we got 2z plus 9 equals negative 2 over 3? Incorrect, okay? This one was no solution. Okay? Now, I went ahead and solved it, okay, just because I wanted to. But this one, we should have stopped at this point and written no solution. I wanted you guys to get the practice, though, making it positive and making it negative, okay? But on a quiz or a test, you do not have to solve this problem. If you ever have an absolute value of anything equals a negative number, it's no solution, okay? All right, your homework. All right, solving absolute value inequalities, okay? So in this case, this is where we're solving absolute values, but instead of an equal sign, it's going to be an inequality. It's going to be the same steps, okay? But there's like some small changes, all right? Back to on the left. So, solving absolute value inequalities. For this first one, okay? First step is always going to be we need to make sure that our absolute value has been isolated. So n minus 1 less than 2. Step number 1. Has it been isolated? Yes, it has. There's nothing on the left side of the inequality that's outside of the absolute value, right? Everything on the left is inside of our absolute value. So we're good to go there. So step number 2 is just to write a positive and a negative solution, okay? So this is going to be n minus 1. You're going to take away the absolute value and leave it the exact same. So it's going to be less than 2. When you write your negative solution, so where you make the right side negative, it's going to be n minus 1 greater than, flip your sign, and make it a negative 2. Okay? So I'm going to highlight the flipped sign and the negative sign. Okay? Because when you change it to your negative solution for the second step, remember how we write a positive and a negative solution, you have to flip the sign and the inequality, okay? So now, what we're going to do is we're just going to add 1 to both sides on both of these. On the left one, we're going to get n is less than 3. And on the right, we're going to get n is greater than negative 1. Okay? If we found negative 1, which was right here, and we shaded to the right, and then we found 3 and shaded to the left, we would get this region in between. Notice how they're open circles because it's less than, not less than or equal to, and it's greater than and not greater than or equal to. Okay? All right. Let's do the same thing for this one. So step number 1. N minus 1 in absolute value is greater than 2. Does this absolute value, is it alone on the left side? Is it isolated? Yes. Okay, we've checked that. Second step, we have to write a positive and a negative solution. The positive solution, n minus 1, keep everything the same, just take away the absolute value. So this looks exactly the same. All we've gotten rid of are those absolute values, okay? Next, now we write our negative solution. N minus 1 is less than negative 2. I'm going to go ahead and highlight what I changed. I flipped the inequality and changed the sign on the right side. Okay, that's how we get our negative solution. From here, you're just going to add 1 to both sides. You get n, oops, let me write in blue, n is greater than 3. Add 1, n is less than negative 1. If we were to graph this, we would go at negative 1, open circle, and shade to the left, because n must be less than negative 1. And then n also needs to be greater than 3. So at 3, open circle, and shading to the right, just like we see up in this graph, okay? So this second one is an example of an or, and this first one is an example of an and, okay? An and inequality, compound inequality, versus an or compound inequality. Remember, with or, you're shading into infinity on either side, and with and, you're shading a region in the middle. All the way back slide. Okay, solving an absolute value inequality. Let's do another example, okay? Without our graph, we're just gonna start from scratch, and then at the end, we're gonna graph our solution. So, step number 1, absolute value of 8n is greater than or equal to 24. We gotta check, is our absolute value completely alone on the left side? Even though there's an 8n inside, is there anything outside of the absolute value on the left side? No. Our inequality is good to go. We've checked. So now we're just gonna write our positive and our negative solution. Remember, our positive solution is just gonna keep everything the same. So it's gonna be 8n is greater than or equal to 24. Everything stays positive, nothing changed. Second part, I'm going to put it in green. It's going to be 8n. Keep the left side the same, the side with the absolute value. Flip your sign and change the sign of the 24. So this becomes negative 24. Okay, I'm going to highlight what I changed again. Okay, I changed, flip this sign, and I also changed the sign of the 24. Okay, next we have to divide by 8. Divide by 8. We're going to get n is greater than or equal to 24 divided by 8 is just 3. So n must be greater than or equal to 3. We're going to box that in. That's one of our inequalities. And our second inequality, you have to divide by 8 again. Divide by 8. Oops, that's a really bad 8. And what we're going to get is n is less than or equal to negative 24 divided by 8 is negative 3. Now, even though we got a negative 3 on the right, the reason we didn't flip the sign, remember guys, is it depends on what we're dividing by. So we divided by a positive 8, okay? It wasn't a negative 8. If it was a negative 8, then we would flip our inequality, but in this case, it's not, so we're gonna leave it the same, okay? We've got our two criteria, so let's go ahead and graph this. Here's our number line. Let's put a 0, let's put a negative 3, and let's put a positive 3, okay? N has to be greater than or equal to 3. So at 3, we're going to have a closed circle. And if n is greater than 3, n can be anything bigger than 3, that's going to be this region over here to the right. Because all these values to the right of 3 are bigger than 3, right? Because like 4 would lie over there, 6 would lie over there, so those all have to be shaded. Now at negative 3, n is less than or equal to negative 3, so it's going to be a closed circle again, because it's equal to. It can be negative 3, and we're going to shade it to the left, okay? So this is an example of an or compound inequality, okay? Because it's n greater than or equal to 3, or n less than or equal to negative 3. All right, perfect. Go all ahead and... All right, we got our lesson check. How do you know, solve, and graph each equation or inequality? Number 1, absolute value of x equals 5. That means, so step number 1, is our absolute value isolated? Yes. So we're done, okay? It is completely on the left side by itself, nothing else around it, okay? So step number 2, positive solution, x equals 5, and our negative solution, x equals -5, okay? Remember, when you're writing a positive and negative solution for an equation, right, where it's equal to, not an inequality, you don't have to change anything, right? You're just going to write x equals +5, x equals -5. All right, next one. We're going to graph it. Here's 0, here's -5, and here is +5. X could be +5, x could be -5. Very nice. All right, number 2. I don't want to run out of space, so I'm going to put number 2 over here. Absolute value of n, oops. -3 equals 4. Remember, step number 1, is our absolute value isolated? No, it is not. So what do we have to do? We have to isolate it by adding 3 to both sides. This becomes absolute value of n equals, the 3's cancel, and now it's 4 plus 3, which is just 7. Now we've isolated our absolute value. It is alone on the left side. All we care about is or what's outside of the absolute value has gone away. So step number 2, we're going to write a positive solution. So n equals 7 and n equals -7, our negative solution, okay? And if we want to graph this, which we do, here is 7, here is -7, here is 0, and n can be both of these. So we're going to shade them in as closed dots. Remember, no shading of the number line occurs because it's an equation, right? It's not an inequality, all right? Next one. We've got 2t, the absolute value of 2t equals 6. So this is going to be step number 1. Okay, is our inequality isolated? Yes, okay? There's nothing around the absolute value that we can get rid of on the left side. So step number 2, we're going to write both of our solutions, so our positive one and our negative one. So this is going to be 2t equals +6, and also 2t equals -6, okay? Next, we go ahead and solve it. So we're going to divide by 2 to both sides. Divide by 2. Divide by 2. Oops, not -2. Divide by 2. Divide by 2. So now t equals 3 and t equals -3. Put this on a number line. Here's -3. Here's +3. Here's 0. Just nice filled in dots at -3 and 3. Okay, I'm going to do one more. I want you guys to try number 4 on your own. We're going to go over number 5, okay? For number 5, remember, first step, x plus 2 is greater than or equal to 1. Is our absolute value isolated on the left side? Yes, there's nothing else on the left side outside of the absolute value that we can get rid of, okay? So we're going to write our 2 solutions. That's our second step. So x plus 2, remember, leave everything the same, is greater than or equal to 1. And then we're going to write our negative solution. So x plus 2, remember, we're changing the sign of the inequality and also the sign on the right side. I'll highlight what I changed again. I changed this and I changed this, okay? All right. Now, in order to get x by itself, we have to subtract 2. Subtract 2. We get x is greater than or equal to -1. And then we're going to do the same thing over here. Not 1, but 2. -2, -2. And we're going to get x is less than or equal to -3. If we were to graph this, okay, X is going to be greater than or equal to -1. Here's -1. Oops. Let me put 0 over here. Here's -1. Closed circle. So X has to be greater than -1. So we're going to shade to the right. And then X also has to be less than or equal to -3. So let's find -3. Closed circle. And we're shading to the left. Okay? This is an OR. Slides gets in our started. All right, and here's your exit ticket. So I want you guys to explain why the absolute value equation, absolute value 3x plus 8 equals 5, has no solution. So explain to me why it has no solution. And let's go over this one. So we've got 3x plus 8 equals 5. Well, first of all, our first step, we want to make sure that our absolute value is isolated. It's not, so we have to subtract 8 from both sides. Once we do that, this is 3x equals -3. Question, can absolute value ever be negative? No, it cannot. So whenever you have the absolute value of anything equals a negative number, this is no solution. Okay, absolute value cannot be negative. Okay, so if we go back, and good luck.